Hi everyone, and welcome to the 2020 Summer PopUps. I'm Sherry Lewin, and I'm the founder and president of Thrive Claremont, and we're happy to have you with us here today. Thrive Claremont is a 501c3 charitable nonprofit. Our mission is empowering teens to succeed, and we do that by providing opportunities for skill building, socialization, and leadership training. One of the opportunities is our Summer PopUps Series. This is our fourth year holding the series and our first year doing so virtually. So we hope you have a great time and we're glad you're with us. But Mark Guillette is a NASA Solar Ambassador. He works full-time as a professor of sociology at Valencia College. He is a member of the Florida Astronomical Society. Fun fact, he's visited all 50 states, 7 continents, and more than 60 countries. And I was just telling someone I have 34 on my list of states visited, so I'm hoping to get there, Mark. But we're really excited. Mark has a wealth of knowledge related to NASA, and he's excited to share it with you. So I'm going to turn it over at this time to you, Mark.
Welcome to my presentation. As Sherry said, my name is Mark Guillette. I am a sociology professor at Valencia College. In addition to that, I'm also what's called a solar system ambassador. See if I can get my screen to go forward here. And that is a program that is run by NASA out of the Jet Propulsion Laboratory in Pasadena, California. And so what I do as a solar system ambassador is I do presentations much like what I'm doing for you tonight. I might go to the local library. I do presentations at Valencia College. I do some YouTube live events, and I just talk about a variety of issues that NASA is involved with. So I'm going to share some of those with you tonight. And so here's our very brief agenda. I want to talk a little bit about the history of NASA. I'm sure that you've probably heard about the Apollo program and the Space Shuttle program. And then we're going to transition and talk about, well, what's happening now? We'll talk a little bit about the International Space Station, talk about satellites, landers, and rovers, and we will talk about what NASA calls the Commercial Crew Program. Something really big happened 3 days ago, and I'll bring that up when we talk about the Commercial Crew Program. And then we're going to talk a few minutes about, well, what's coming up? And there are 2 real big events that will be coming relatively soon. One will be our return to the moon, and the other one will be the launch of a very large, expensive telescope called the James Webb Space Telescope. And then with whatever time we have left over, I'm going to show you a few things how you can get involved once we get offline. All right, so is everybody good? I see one person waving their head up and down. All right, very good. Again, ask questions, get involved. So, can anyone tell me what NASA stands for? Not all at once. Anyone tell me, does anyone know what NASA stands for? Anyone, NASA? It's an acronym? No. National Aeronautics and Space Administration. Let's see, am I getting something in the chat here? Let's see if I can see if there's where the chat is. Nope, not seeing it there.
In the chat, Seth said National Aeronautics and Space Administration.
All right, very good. I'm not seeing my chat here.
Go down to the bottom, or once you share, everything will come at the top.
No, it's not coming at the top.
Okay, so maybe you can't see the chat?
I don't know why I shouldn't be able to see it. I see
the same toolbar as the mute and unmute.
Yeah.
No chat.
No, I don't see the chat showing up.
We'll monitor and let you know.
Okay. All right, very good.
So Seth got it.
All right, Seth is correct. All right, so let's move on and go back to the Apollo program. Now, before NASA started the Apollo program, there were 2 programs before that, Project Mercury and Project Gemini. Both of those two projects led up to us going to the moon. And the Apollo program was all about going to the moon. And so last year, actually July 20th, 1969, it's been 50 years, that was the first time that we went to the moon. So I have a very short little video here that I'd like to show you about us going to the moon.
I was 3 years old. But that's weird though. I mean, I was alive when it happened.
I still can't fathom how some people say.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
We have ignition sequence start. Engines on. 5, 4, 3, 2.
Listen, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind. We leave as we came, and God willing, as we shall return, with peace and hope for all mankind. On our way, Houston.
From 1969 to 1972, we had a total of 6 moon landings. 12 humans walked on the surface of the moon. We have elevated the human condition. We have improved human lives. We have raised the standard of living for every person on Earth because of space exploration.
All right. Pretty cool, isn't it? So that rocket that you saw take off was called the Saturn V. And it was called the Saturn V because it had 5 main engines. It took a lot of power to get that rocket out of Earth's atmosphere. But when the astronauts came back, they came back in just this little capsule right here. And that was right on the very top of the Saturn V rocket right there. Okay? So, following the Apollo program, there was the Space Shuttle program. And the Space Shuttle program was from 1981 to 2011. There were 135 launches of 5 different space shuttles. When the Space Shuttle went up into space, does anyone happen to know how far up in space it would go? Any guesses on that? Anyone's, let's see, wait a minute, am I seeing the chat here? All right, I do see the chat now. Any guesses on how many miles above the Earth the Space Shuttle would orbit the Earth? Anyone want to guess? Any guesses? 1? No? A little more than 1 mile. It was about 250 miles above the Earth. 250. Any guesses on how fast they were traveling around the Earth? Give me a guess how fast they were going in miles per hour. Yep, okay, 15,000. All right, 17,500 miles an hour, Morgan. So you're pretty darn close. All right, so what they would do is they would go into what's called low Earth orbit, and they would often go to the International Space Station that I will be talking about in a few minutes. And they would basically just shuttle astronauts back and forth into low Earth orbit. Let's see, I see Chantel, to get into orbit, they need to go about 7 miles per second. Yes, they're going very, very, very fast. Now, have any of you ever been over to the Kennedy Space Center Visitor Complex? Yes. Well, if you haven't been, if you do get the opportunity, I highly recommend it. On the left-hand side of your screen, you will see one of the 5 original shuttles that actually went into space. They have it on display again at the Kennedy Space Center Visitor Complex, and they did an awesome job. If you ever get out to California, on the right-hand side of your screen, you can see another shuttle, the Endeavour, at the California Science Center. But the Kennedy Space Center Visitor Complex is a lot closer. So if you get the opportunity, I highly recommend that you go check it out because it's the real thing. It's not a model, it's the real thing. All right, so this is a pretty cool little picture that's on your screen. And what this is showing is all of the different missions and projects that NASA is currently a part of or will be. And I say will be because if it's in all caps, like the ones that you see here that I'm pointing out, these are future missions. The ones that are in lower caps are past or current missions. And so, for example, you've probably heard of the, where is it? I don't see it. Hubble, there it is, the Hubble Space Telescope. I'll talk a little bit about that in a few minutes. It's there. The Spitzer Space Telescope was retired back earlier this year. I mentioned the Webb Space Telescope in the introduction. I'll talk a little bit about that later on. These are all telescopes that are doing observations of the universe. But then we have the planet Mars here. We have a big launch coming up next month on July the 17th, the Mars 2020 rover. I'll spend a couple minutes talking about that in a few minutes. We have missions that are going around the sun, the Parker Solar Probe, Voyager 1 and Voyager 2, two satellites that were launched many years ago, 1977, that are trillions of miles away from Earth. So a lot of things are going on with NASA. All right, let's transition to what's happening now. So the International Space Station was built by many different countries all over the world. It was first inhabited in the year 2000. That's the first time that astronauts started living on the International Space Station. Does anyone happen to know how fast the International Space Station is traveling? And by the way, there's a picture right here. This is what it looks like in space. Any ideas how fast that is traveling in space? I'll give you a hint. Morgan was very close to the speed when she put her original one up there. Her original guess on 16,000. Yeah, I see a lot of, so they're going about 16,000, 17,500 miles per hour. That's how fast that's traveling around the Earth. So it takes about 90 minutes for the International Space Station to completely orbit the Earth. There are currently 5 astronauts on the International Space Station. All right, 3 of them are with what's called Expedition 63, 1 American and 2 Russians. But on Saturday, there were 2 more astronauts that launched from Kennedy Space Center and that they docked on Sunday. All right, and I'm going to talk about them in a few minutes. So they're going really, really fast. They're also about 250 miles above the Earth. So they aren't very, very far away. All right, but what are they doing up there? They're doing a lot of science. They're doing a lot of research that can't be done on Earth because naturally up in space, there's no gravity. All right, so I see a question here from Sherry. How do they name the telescopes or missions? Quite often when it comes to the telescopes, they honor someone by naming a telescope after them. For example, the James Webb Space Telescope that is scheduled to be launched next year was named after NASA's second administrator. The Hubble Space Telescope was named after Edwin Hubble, an astronomer back in the early to mid-1900s that did a lot of research in astronomy. So they often name these to honor different people that have worked for NASA or that are in astronomy. Now here's something that you can do that's really cool. If you don't already know about this, you can go to a website. It's called spotthestation.nasa.gov. And when you go to this website, there is a place where you can sign up for email alerts. And it's right here. I'm not going to go through the registration process. It's very easy. It's self-explanatory. But when you sign up for alerts, what will happen is, let me go back to my original screen here. Okay, what will happen is you will receive an email generally about 12 to 18 hours before you can see the International Space Station from where you are. So you will get the email. It will tell you the day, the time, and where you need to look in the sky to see it. So this is a picture that I took with my phone, my cell phone. So when you go out and look at it, it will not look like this. Okay, it's too far away. The International Space Station is roughly about the size of a football field. What it's going to look like is a little dot in the sky, a little white dot like this. But what's really cool is, as you see this little white dot go across the sky, you can think about how there are several astronauts in that thing traveling at 17,500 miles per hour, orbiting the Earth every 90 minutes. And so that to me is pretty exciting to think about what that little white dot represents. What do you all think? Would that be pretty exciting? How many of you would like to be able to go to space if given the opportunity? Logan, Morgan, yes. Chantel, seen it. I would like to. Seth, yeah. I would love the opportunity too, and hopefully sometime in the near future, there are going to be private companies will be offering space tourism. So for a healthy amount of money, if you have a healthy amount of money, you can jump on a rocket and go into space for maybe a few hours. And if you have a lot of money, you can go to the International Space Station and stay a day or two and see what it's like to go into space. We've never had that opportunity before, so hopefully that opportunity will come soon and will really give us a new view on our place on planet Earth. Here are some other things that are currently happening at NASA. I mentioned Voyager 1 and Voyager 2 earlier. Both of these satellites, this is kind of like an image of what they look like. They were both launched from Kennedy Space Center in 1977. And they are really, 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 really far away. They are so far away that when NASA sends computer commands to these satellites, it takes 17 hours to get the communication there. That's how far away they are. And then when they want to download information from these two satellites, it takes 17 hours to get the data from the satellite back to planet Earth. So you're talking about what? 34 hours to send a message and then to get information back. That's using radio telescopes. And that should give you an idea of how far away these are. They're really, really far. Again, if you have any questions or anything, please, feel free to ask as I go along. On the right-hand side, you see the Hubble Space Telescope. It was launched on one of the space shuttles that I was mentioning earlier back in 1990. So now it has been up in space about 350 miles above us for 30 years. And chances are, if you ever see pictures from NASA that might be online or in a magazine, there's a pretty good chance that those pictures come from the Hubble Space Telescope. Okay, it's about the size of a bus, and it's a really neat, cool piece of equipment. The Hubble Space Telescope is kind of like having a telescope on Earth. I'm sure that you all are familiar with telescopes on Earth, but this is one in space. Does anyone know why we want to put a telescope into space? Why don't we simply use the telescopes that we have here on planet Earth? Why? It costs a lot of money to build these and to put them into space. Anyone know why we'd want to do that? So again, any ideas about why we would want to put a telescope into space rather than looking at space from Earth-based telescopes? To reduce interference between the object photographed and the telescope, okay? And so what kind of interference? So Chantel, you're right. Reduce interference. What kind of interference are you thinking about? Because you're certainly on the right path. Telescopes on land can't see the planets. Actually, telescopes on land can, if they're big enough, they can see the planets because they would stretch farther. You can see farther because of some interference that Chantel talked about. Okay, clouds and just gases in general. All right, yes, clouds, and clouds are part of our atmosphere. The Earth has an atmosphere, and the atmosphere has liquid water, it has other gases, and so when we try to use Earth-based telescopes to look into space, we have to look through our atmosphere, which can kind of distort what we're looking at. So if we can get a telescope above our atmosphere, like the Hubble Space Telescope, we don't have to worry about the clouds and the dust that make up our atmosphere, which allows us to see much further, much deeper in the space, and gives us a much clearer view. I saw that Sherry asked a question about how long do they last. Generally, most of these things, not only the satellites I'm going to talk about, but also the rovers and the landers in just one moment, they end up lasting a lot longer than what they are designed to last. Sometimes they may be designed to last only a few months, but will end up lasting for years. And why are we being told that they may not last that long? Well, because when you put things into space or you land things on other planets, there are lots of challenges. Like, for example, if you land something on Mars, you have a lot of dust storms. And the landers and rovers on Mars will use solar power to power them. And so if a sandstorm comes through and it puts sand all over the solar panels, there's not going to be enough light to power the lander or rover. So, but generally these do last a lot longer than what they are designed to last. All right, everybody doing okay? Can anyone give me the thumbs up? All right, here's probably the most famous picture that the Hubble Space Telescope ever took. And so what scientists decided to do was, they said, okay, we're gonna point the Hubble Space Telescope in one very obscure part of the sky. And they picked a part of the sky that they thought, okay, this is boring, there's nothing there. Let's basically focus the cameras on Hubble in this very small, tiny section of the sky that we think is boring. Let's take a whole bunch of pictures and see when you take pictures, astrophotography pictures, it's all about collecting light. That's what you're doing. And so the more pictures you take, the more light you can collect. And so it took a whole bunch of pictures, it put them all together, and scientists went, oh my God, and they were shocked at what they saw, because this is what they saw. They saw a very small section of the sky that they thought was boring, ended up having over 10,000 galaxies. Now keep in mind that we live in one galaxy called the Milky Way galaxy that has hundreds of billions of stars. Now each one of these that you are looking at here in this picture, this one, all of these, most of these are all galaxies. all of them have billions and billions and billions of stars. And so scientists are saying, okay, well, if we picked a very boring section of the sky and look what we found, imagine all the other parts of the sky that we haven't looked at yet. So this is basically showing us that there are perhaps billions upon billions upon billions of other galaxies out in the universe. All of these galaxies, again, are made up of billions and billions of stars. And now we know that on average, every star has at least one what's called exoplanet. And an exoplanet is a planet that is outside of our solar system. So what does that tell us? That tells us that there are billions and billions and billions of planets out in the universe. And then that brings up the question, well, is there life out there? We don't know. My best guess is probably there is something, but we won't go too far down that road right now. Landers and rovers. So back in November of 2018, JPL, part of NASA, sent the Mars InSight lander to Mars. And so here is an image of the InSight lander. It's a lander, which means that it landed on Mars and it has no wheels. We're going to talk about this rover in a moment. See, this rover has wheels so it can move around. This lander doesn't have any wheels. So when it lands, it's going to stay in that one specific spot and not move. So they want to make sure that when they landed in the right place. Now think that Mars is about roughly 40 to 45 million miles away. And they need to land it in a very precise area. And they do it. So there's a lot of work that goes into all of these projects that NASA is a part of. And you might consider becoming a part of this if space exploration is something that's interesting to you. And what you want to do is you want to make sure that in school you do a good job of studying for your classes. You take a lot of science classes, technology, engineering, mathematics, STEM classes, because if you go to work for NASA, that's what they're looking for. They're looking for people that have graduated that have a lot of experience in those fields. All right, on the right-hand side, you have the Mars Curiosity rover that landed on Mars back in August of 2012. And so this goes back, Sherry, to a question you had. How long do these things last? They never thought that this rover would last this long. Okay, they probably designed it to last a few months, but here it is, June of 2012, and it's still doing some work on Mars. So that's pretty fabulous. All right, let me keep us moving because I still have quite a few things I want to show you. Mark your calendar for next month, July 17th. JPL and NASA will be launching its newest rover. It was originally called Mars 2020, but an American student back in March, a few months ago, named it Perseverance. So that's the name of the new rover, and it's going to be launched from Cape Canaveral right down the road next month in about, 6 weeks. So all you have to do is mark your calendar for July 17th, and you have to find out the very specific time, go online, and you can walk out your door, and if it's a clear day, you can see this thing. Here's an image of it on the left-hand side that is being launched right in our back door, and it is scheduled to land in February of 2021 on Mars. Okay. On the right-hand side of your screen, you see what's really cool, a helicopter. There's a helicopter that is mounted on the bottom of this rover, and when they land this rover on Mars, this helicopter will detach and they're going to fly it around. And this is the very first time that NASA has ever flown a helicopter anywhere outside of our own planet. So that's a pretty cool thing. All right, let's move on. Now, NASA's Commercial Crew Program. I talked about the Space Shuttle earlier. The Space Shuttle program ended in 2011. That was 9 years ago. But there was a problem. The problem was we did not have a way of getting our American astronauts to the International Space Station. So what we have been doing is we have been paying the Russian government to take our American astronauts with their Russian cosmonauts up to the International Space Station. But NASA decided to find private companies, I bet you've probably heard of SpaceX and also Boeing, to build rockets and capsules to take astronauts back and forth. And so just 3 days ago, and I'd like to know, did any of you watch the launch on TV, online? Did you go outside and watch it? And did you see the launch of the SpaceX Crew Dragon? Did anyone see that? So I see that Morgan saw it, Sherry saw it, watched it live on YouTube. Logan, great. Jordan, yes. Well, I actually drove over to Melbourne, which is a little closer than where I live in Davenport, and I was able to see it from a distance. It was a little cloudy that day. I see Seth didn't get to see it. But it was really cool because that's the first time in 9 years that we have launched American astronauts from American soil. And so if you look on the left-hand side of your screen, this is the Crew Dragon. This is what SpaceX, a private company, built. You've probably heard of Elon Musk. He is the founder of SpaceX. The astronauts were in this capsule on top of this Falcon 9 rocket, and they launched. And the next day, Sunday, 19 hours later, they docked with the International Space Station. They're going to be there for a few weeks. They could be out there up to 2 months. And then eventually they're going to get back into the capsule, and then they're going to return here to Earth. So that's something you probably want to keep an eye on because it's going to be really big news to make sure that everything goes well because they're doing some tests. They're doing the first major test of this Crew Dragon. So it really neat stuff that's going on. All right. What do I have next? And so there you go. It was called Launch America. It was Saturday at 3:22 p.m. On the right-hand side, you see Doug Hurley, and you see, what's his first name? Ben Bankins? I think that's his name, Ben. These are the two astronauts that launched on Saturday. So cool stuff. All right, James Webb Space Telescope. I mentioned this earlier. This is going to be launched next year from South America. This will operate at about 1,000 miles away from Earth. Now, keep in mind, I talked about the Hubble Space Telescope a few minutes ago. That's only about 200 to 350 miles above the Earth. This is going to be 1 million miles away from Earth. And the reason it's going to be so far away is because this is an infrared telescope, which is extremely sensitive to heat. And if it was to be orbiting the Earth at about 200 to 350 miles above the Earth actually gives off heat and will not allow this telescope to work properly. So they have to get it far away from the Earth in order for it to be in very cold conditions. So I'm going to show you this very short little video. I hope it works. I often have issues getting it to work when I do these online presentations, so I'll cross my fingers and hope that it will work for us. Sometimes it starts and stops, so I'll give it a couple tries, and if it doesn't want to work, then you can go back and look it up online on your own. Let's give it a minute here. So it's a pretty neat video.
The James.
Why do they build the telescopes? What do they build them out of? That is a very good question. I'm not an engineer. I don't work with them. Metals.
Webb Space Telescope.
Let's see if I can get this thing to play
is the
here.
next premier space observatory. It will extend the discoveries of the Hubble Space Telescope and observe the birthplaces of planets, stars, and galaxies. It is named after James Webb, NASA's second administrator and champion.
Uh-oh. So what do they build them out of? Metals, different composites. They have to be very careful what they build these out of because they have to be able to survive in very hostile conditions up in space. So I'm not sure why this video gives me so many problems. It's not from my computer. It's not from the internet. It's something to do. I often have issues with this video from wherever it's hosted. So I'll give it one more chance to play, and if it stops, I'll stop it.
At 3 stories high and the size of a tennis court, this will be the largest telescope ever sent into space, and 100 times more powerful than Hubble. It is so big it has to fold to fit into the rocket only 5.5 meters wide. An unfold segment.
All right. So what you can do is you can go online after the presentation and look up Goddard Media Studios and James Webb Space Telescope, and you can watch this. But I don't want to spend our time waiting for this thing to load. So I'm going to go back and keep us moving. All right. What's the next big thing coming up at NASA? It's the Space Launch System. It is the new rocket that's being built that will return us, the first woman, yes, we need a woman, to go to the moon, and the next man. So this rocket will be used not only to take us to the moon, but eventually this same rocket that's being built will take us on to Mars. This is the official logo of the Artemis program. Does anyone happen to know about Artemis? Does anyone know where that name comes from? I'll give you a hint. It has something to do with Apollo. Remember Apollo that I spoke of earlier? Does anyone know the relationship of Artemis to Apollo? It's his dog. No, you're all kind of on the right track. It's Apollo something. It's not his dog. It's Apollo's sister. Yes, Logan. It's his sister, twin sister. And so that's what they decided to name the next program, the Artemis program. His twin sister, yes. All right. So let me show you. Here's the rocket that's being built. It's a heavy lift, deep space hardware rocket. What does that mean? It's really, really, really big. When completed, it will be the most powerful rocket ever built. It's evolvable, which means that it can be used to do different things. In these two configurations, it can be used to take astronauts to the moon and into deep space. In this configuration, it can be used to launch things like rovers and satellites. All right. Artemis 1, the first full test of this brand new rocket that NASA's building, is next year. Right now, it's scheduled for November of 2021, so less than a year and a half from now. When they launch this from Kennedy Space Center, so if it's clear, you can walk out your door and look over to the east and see it launching. It will not have any astronauts on it, but it's going to be launched to the moon. It's going to go around the moon 1 or 2 times. It's going to be out in space for about 30 to 45 days, and then it's going to come back. And what's the reason for all of this? They're going to test it. They're going to do a lot of testing on the hardware and the software. If all of that goes well, then in the year 2022 or 2023, the next major test will happen, and that's called Artemis 2. What happens on Artemis 2? Well, they're going to put 4 astronauts in the Orion capsule, which will be right there. I'll talk about the Orion capsule in a moment. And they're going to send them around the moon. Okay, this will be the first time since 1972 that humans have orbited the moon. They're not going to land on the moon. They're just going to orbit the moon. If that test goes well, then Artemis 3, scheduled currently for 2024, this rocket will launch with up to 4 astronauts, and the plan is to go to the moon and land on the moon again. Okay, so pretty exciting. I spoke a moment ago about the Orion crew capsule. So this here is where the astronauts will go, and that will be right here. They're going to put that right on the top of the rocket right there. Okay. This capsule, when it returns to Earth, will be returning at over 24,000 miles per hour. Remember earlier I talked about the space shuttle. It would travel at about 17,500 miles an hour. But this travels significantly faster. This can accommodate up to 5 astronauts. NASA has plans for 4. All right, so here's a short little video about the SLS and Orion program.
50 years ago, we pioneered the path to the moon. The trail we blazed cut through the fictions of science and showed us all what was possible. Today, our calling to explore is even greater. To go farther, we must be able to sustain missions of greater distance and duration. We must use the resources we find at our destinations. We must overcome radiation, isolation, gravity, and extreme environments like never before. These are the challenges we face to push the bounds of humanity. We're going to the moon to stay by 2024, and this is how.
This all starts with the ability to get larger, heavier payloads off planet and beyond Earth's gravity.
For this, we designed an entirely new rocket.
The Space Launch System. SLS will be the most powerful rocket ever developed.
And with components in production
And more in testing?
this system is capable of being the catalyst for deep space missions. We need a capsule that can support humans from launch
through deep space and return safely back to Earth.
For this, we built Orion.
This is NASA's next generation human space capsule.
Using data from lunar orbiters that continue to reveal the moon's hazards and resources,
we're currently developing an entirely new approach to landing and operating on the moon. Using our commercial partners to deliver science instruments and robotics to the surface, we are paving the way for human missions in 2024.
our charge is to go quickly and stay. Forward with a fervor that will see us return to the moon in a manner that is wholly different.
We want lunar landers that are reusable.
That can land anywhere on the lunar surface. The simplest way to do so is to give them a platform in orbit around the moon from which to transition.
An orbiting platform to host deep space experiments and be a waypoint for human capsules. We call this lunar outpost Gateway.
The beauty of the Gateway is that it can be moved between orbits
It will balance between the Earth and Moon's gravity.
in a position that is ideal for launching even deeper space missions.
In 2009, we learned that the moon contains millions of tons of water ice.
This ice can be extracted and purified for water, and we separate an oxygen for breathing or hydrogen for rocket fuel.
The moon is quite uniquely suited
to prepare us and propel us to Mars and beyond.
This is what we are building.
This is what we're training for.
This we can replicate throughout the solar system.
This is the next chapter of human space exploration.
Humans are the most fragile element of this entire endeavor, and yet we go for humanity. We go to the moon and on to Mars to seek knowledge and understanding and to share it with all. We go knowing our efforts will create opportunities that cannot be foreseen. We go because we are destined to explore and see with our own eyes. We turn towards the moon now, not as a conclusion, but as preparation, as a checkpoint toward all that lies beyond. Our greatest adventures remain ahead of us. We are going.
We're going.
We are going.
We are going.
We're going.
All right. Isn't that cool? Neat stuff. All right. So I'm going to skip those two, and I'm going to take us to Experience NASA for Yourself to wrap this up. I highly recommend that if you haven't done so already, go to nasa.gov, nasa.gov. There, you could spend hours and hours on this website learning about all of the different past, current, and future missions of NASA. You can find out what they're doing on the International Space Station. You can see all kinds of cool pictures that they've taken. So nasa.gov. And this is a really, really, really cool website. It's called NASA Eyes. So don't forget about this after we get done. NASA Eyes, remember that. Now I'm going to go to my desktop and I'm going to show you, I've already downloaded a little icon that I've put on my desktop. And this NASA Eyes program is really cool. So let me demonstrate it for a moment. I know we're getting towards the top of the hour, so I want to leave a couple minutes for questions. But with this software that was created by JPL in California, you can do some really cool things. You can look at our solar system. You can turn it all around. All right, you can see, all right, there's the sun. Here's the Earth. You can zoom in. If I can get my computer to cooperate with me, give me 1 second here. Okay, you can zoom in. I talked about the Parker Solar Probe earlier. All right, it's doing some research around the sun. This is where the Parker Solar Probe is actually located. If you want to go down here, you can go to the time and date. And if you decided, okay, I want to see what it's going to look like on July the 2nd, you type in July 2nd, and you can see that it's already past the sun and going away again. So you can go back in time, you can go forward in time. I talked about the Voyager 1 and Voyager 2 satellites. All right, there's Voyager 2. It's left our solar system. It's an interstellar space. You can click on the title of it, and it will tell you all kinds of cool information about Voyager 1, Voyager 2. You can look at the satellites up close, turn them around. So some really cool software. NASA Eyes, that's what you want to look for. All right, so I'm going to shut that down, and I'm going to go back here, and I'm going to go here, current, and questions. Who's got questions for me? All right, let's see here. What is the advantages of a solid rocket engine? Advantages of a solid rocket engine. I'm sorry, I cannot answer that question. I'm not an engineer, and I don't have the appropriate information to be able to appropriately answer it, so I'm going to pass on that. What would happen with the telescopes when they reach the end of their lifespan? What would NASA do with them? All right, so what often happens with things like these telescopes is that they will eventually come down. What goes up will come down. Not all of them, but the ones that are in low Earth orbit. So, for example, eventually the Hubble Space Telescope will come down, and it will be a controlled deorbit over an ocean, and it will basically break up, and there won't be much left to it once it gets back into our atmosphere. If it's far out, like Voyager or like the James Webb Space Telescope that I mentioned earlier, they're going to be left out into space, okay? There's more and more what's called space junk that's up there, and that is a very big concern for people, the astronauts on the International Space Station, because if one of these things come and hit the side of the International Space Station, going at 17,500 miles per hour, well, it's not going to be a good day for the astronauts. How will the astronaut transport device power up to leave space station? How will it land on Earth? How will the astronaut transport device? So I'm thinking, Sherry, that you're talking about like the Crew Dragon that launched on Saturday.
Yeah, once they get there, how do they what powers them back?
Yep, so they have small, what's called Draco engines on the Crew Dragon that will very slowly move it away from the International Space Station. And once they're far enough away, then they will fire up a larger engine that they have that will get them prepared to do a deorbit burn, which will get them coming back through our atmosphere.
Okay.
How much food and water can be stored in the astronaut's capsule? The one that I was showing you earlier, not a whole lot. I can't tell you an exact amount, like if it's a month or 5 months, but they don't have a lot of room inside of those. So what they do is they have other launches that launch supplies to the International Space Station, and Elon Musk, his company SpaceX, they generally will do a launch to the International Space Station about every 6 weeks, every 8 weeks. A really cool website to go to is Space Flight Now. If you look that up, Space Flight Now, it will tell you of all the launches that are coming up all over the world. So if you want to be aware of when the next launch is here at Kennedy Space Center or Cape Canaveral, you will see it on that list and you can go outside and watch it as it happens. Let's see, if it poses a threat to something, then will they crash it intentionally? I would say that if it posed a threat, a significant threat, they would do something to try to mitigate any damage of property or the death of astronauts. I don't know that they'd have to crash it. They could simply move it into a different orbit. There was one satellite orbiting Jupiter, and they were worried it would hit a moon that would support life, so they crashed into Jupiter. Yes, the Juno mission. And so they intentionally crashed it into Jupiter for the reason that you have indeed stated. They don't want to take the chance that any living organisms was on that satellite when it goes around when it went around one of the moons of Jupiter. And so if we find life on one of the moons of Jupiter, we want to make sure that we didn't bring the life there. And so that's why they crashed it intentionally into Jupiter. The U.S. just commissioned a new branch of the military focusing on defending our satellites, the Space Force. What is your take on this new branch, and is there a great need for defending satellites? I would rather not give my opinion about a new division of the military. I'm sorry. All right, any other questions? Because you did ask for my take on it, and so I want to, Alicia, I'm sorry.
That's okay. We were talking about it earlier, and yeah, so we were wondering.
Yeah.
Question I have is, I know that last summer, this is just a general, we had a scheduled pop-up night where a solar telescope was to come, and then it got, there were lots of things that happened. But is that still something that you do, Mark? And would there be a chance to schedule a time to have the solar telescope out in the Claremont area?
I don't do that. The Central Florida Astronomical Society has outreach programs, and they do that. Let me share one more thing with the